Hello everyone, this is our presentation about Omni Antenna, and this is our group member. First topic that we talk about is what is an omnidirectional antenna? An omnidirectional antenna is an antenna designed to send and receive equal amount of signal in all horizontal directional. What do we mean by horizontal directional? An antenna have a certain amount of gain associated with them, which we will get into later. When gain is applied to an omni antenna, the radiation pattern allows the antenna expand outward, allowing the antenna to reach farther at the cost of emitting less radiation at the top and the bottom. Thus, omni antenna directional are known to have a donut shape, the radiation pattern. The most common omnidirectional antenna is a dipole. A basic dipole antenna looks like a T-split in half. A common example of dipole is the rabbit ear television antenna. Most omnidirectional antennas work in the same way as a dipole. So to understand how they work, we will discussing how a basic dipole works. The following explanation may get a bit technically, but we will try to keep it as simple as possible. Shape and strength. As mentioned, omnidirectional antenna send and receive signal in all horizontal direction from the antenna. If you were to visualize the coverage area for an omni antenna, it would look like a donut with the antenna in the middle. Since the radio waves are being sent in all directions, the strength of the signal is less than you would find from a directional antenna, which concentrates the signal in a specific direction, but you're able to cover a broader area and be less precise on the positioning of the antenna. Omni antennas are typically led by their gain, which describes the shape of the antenna signal and how much width it has. An omnidirectional antenna with a higher gain will have a flatter shape and cover a wider area, and thus will result in a more powerful signal from the cellular provider tower. The next topic is a type of omni antenna. Radiation pattern of a T lambda over 2 monopole antenna or to the radiation of an omnidirectional antenna in symmetrical in azimuthal direction. It may vary in a complicated way with elevation angle having lobe and node at different angles. The most common omnidirectional antenna design are the monopole antenna, consisting of a vertical rod conductor mounted over a conducting ground plane and vertical dipole antenna, consisting of two collinear vertical rods. The quarter wave monopole and half wave dipole both have vertical radiation pattern, consisting of a single broad lobe with maximum radiation in horizontal direction. So they are popular. The quarter wave monopole, the most compact resonant antenna, may be the most widely used antenna in the world. The 5/8 wave monopole with a length of 5/8 equal 0.625 of a wavelength is also popular because at the length a monopole radiates maximum power in horizontal direction. Common type of low-gain omnidirectional antenna are the whip antenna called rubber ducky antenna, cloud plane antenna, vertically oriented dipole antenna, disc cone antenna, mass radiator horizontal loop antenna, sometimes known colloquially as a circular area because of the shape, and the halo antenna. Higher gain omnidirectional antenna can also be built. Higher gain in this case means the antenna radiates less energy at higher and lower elevation, angle, and more in the horizontal direction. High gain omnidirectional antenna are generally realized using collinear dipole array. This consists of multiple half-wave dipoles mounted collinearly in a line, fed in phase. The coaxial collinear antenna use the transport coaxial section to produce in-phase half-wavelength radiator. A flanking array uses short U-shaped half-wavelength section whose radiation cancels in the far field to bring each half-wavelength dipole section into equal phase. Another type is the omnidirectional microstrip antenna.
The radiation pattern of a sample omnidirectional antenna, a vertical half-wave dipole antenna. In this graph, the antenna is at the center of the donut or torus. Radial distance from the center represents the power radiated in that direction. The power radiated is maximum in horizontal directions, dropping to zero directly above and below the antennas. Animations of an omnidirectional half-wave dipole antenna transmitting radio waves. The antennas in the center is two vertical metal rods, which an alternating current applied at its center from a radio transmitter. Loops of electric fields leave the antennas and travel away at the speed of light. These are the radio waves. This diagram only shows the radiations in a single plane through the axis. The radiation is symmetrical about the antennas. Omnidirectional radiation patterns are produced by the simplest practical antennas, monopoles and dipole antennas, consisting of one and two stack rows conductor on a common axis. Antenna's gain is defined as antenna's efficiency multiplied by antenna's directivity. A useful relationship between omnidirectional radiation patterns, directivities, in decibels and half-power beamwidth, based on the assumptions of a size B theta over B theta patterns. Omnidirectional antennas in practice. How does this look in practice? After starting a cellular signal booster, an electrical current will be supplied to the omnidirectional antennas. The antenna's component will create an electromagnetic field around it. The antennas will be exposed to all types of electromagnetic waves, such as radio, TV, and cellular frequencies, but will only grab the ones that fall within the frequencies to signal booster system support, which are cellular frequencies from AT&T, Verizon, T-Mobile, Sprint, US Cellular. The cellular signals are fed to the amplifier via coaxial cable for boosting. Oppositely, when you're sending out information like a text messenger with the boosting signals, the information the messenger contains is converted into radio frequency waves. These waves travel through the signal boosting system and are broadcasted into the air by the outdoor antennas. The waves travel at the speed of light in the directions of where the signal source is located.
When we should an omnidirectional antenna be used, the below information will relate to cellular signals specifically, but the cellular omnidirectional antenna work best in situations where the first one, there are multiple cellular towers nearby, that the multiple cell tower no more than 5 miles away. The antenna will be able to pick up multiple signals from every direction. If the towers are more than 5 miles away, a directional antenna will be the better option. 2. Usable signal is available but nearby obstacles interfere with the signal. Obstacles sitting between nearby cell tower and your home's vehicle or place of work, such as tall buildings, dense foliage, valleys, and bodies of water, can also reflect and reflect incoming radio waves, altering their direction. Since the obstacle causes inconsistent cell reception, you are likely to experience below average signal outdoors and spotty service indoors, even though the signal source is nearby. In this case, the omnidirectional antenna is perfect. It can pick up the inconsistent cell signal from any direction. The amplifier will boost the signal and the indoor antenna will broadcast the boost 5G, 4G LTE, and 3G signal indoor. Sure, a directional antenna would work just as well, maybe even better, but it would only be able to pick up signal from one direction from one or two carriers. If there are multiple towers nearby and you want to pick up signal from multiple cell towers to boost multiple carriers, it's better to use one omnidirectional antenna rather than multiple directional antenna, which if not set up properly can cause additional signal interference. 3. Building material blocks cellular signal. If your cellular signal strength is decent outside but extremely poor outside your home or office, building material is too brown. Metal, concrete, brick, plaster, and low-E glass, to name a few, can weaken or completely block cellular signal from reaching Androids, iPhones, tablets, hotspots, and all cellular devices inside the building. Signal booster system will help bypass any building material blocking the signal from entering and broadcast boost cellular signal for all carriers in the area where it's needed most. The outer antenna can affect the booster's performance. The advantage of omnidirectional antennas. The first one is of installation. 2. Amplify cell signal for multiple carriers with different cell towers in multiple locations. 3. Great for boosting 4G and 5G signal when building material is the main problem of cellular interruption. Next, disadvantage of omnidirectional antennas. The first one, range is less than that of a directional antenna. 2. Not ideal for areas where poor signal, areas where the culprit is cell tower distance. This is all of our presentations in our groups. So thank you for listening.